Okay guys, the eagle-eyed will notice that I've titled this The Sky in October. I normally call it the night sky, but actually I'm going to talk a bit about the day sky, solar cycle 24, because lots been happening on the sun recently. If we have a little look, that's I took that off the satellite feed from the Solar Dynamics Observatory today, and that is the sun in hydrogen alpha. You can see it's a very active surface, and particularly I want to point out there's a huge detached prominence going on down there on that sort of southeast limb of the sun. So I haven't got the standard Earth to scale thing here, but you're looking at sort of several Earths would fit into that area there. It's a huge prominence. It's actually coming away from the surface. Very interesting one to watch. Unfortunately, I haven't seen it myself because the weather at the moment, you know how it is. But just in terms of general activity, if we look back at the last couple of years, so far in 2011 there have been only 2 days with no sunspots at all on the sun. You compare that to last year, 2010, where 14% of all days were spotless, and 2009, where 71% of all days, about over 200 days, were spotless on the sun. But that's how the sun is looking just at the moment. I've got some more pictures from Peter Pace here. Peter's been getting some very good opportunities. I don't know how you sort of fit it in between the weather, actually, Peter, because I must admit I haven't seen nothing sort of the monsoon season myself. But, here we go. Starting on the 23rd and 24th, this was a spot that came round from the eastern limb, active region 1302, and you can see how that's moved there in the course of the day. Sunspots generally take around sort of 25 days to complete an entire revolution around the middle of the sun, so you can see that's a day's worth there. So they'll go from one side to the other in 12 days or so. That's how long a sunspot lasts. And quite often they do last around the other side and come around again, but they do get a new number every time. It just saves confusing matters with some that go away and return. It could be the same sunspot, comes around 25 days later, gets a new number. So moving on, again from the 23rd, that's a close-up that Peter's got of active region 1302. These temperatures around the sort of the yellow area here would be around 6,000 degrees centigrade. Although the sunspots look black and you might think that they were cold, they're only actually relatively cooler. They're still about 4,000 degrees there, and that, again, a sunspot of that size you could fit the entire Earth into. So they're pretty big. From the 28th of September, see how things have moved on. This here now is 1302. It's moved across the centre of the sun, and again, Peter's taken these pictures of this is close up in white light. And you see this is broken up into 2 areas here. They will be magnetically of opposite polarity. It's part of the structure of the sunspot. It sort of it's like a tunnel that goes under the sun and comes out nearby. North and south pole of the magnet, actually. Peter's done this both in hydrogen alpha light here, which shows a lot more of the structure of the sun. That's the light that's particularly good for looking at prominences and so on. And these markings here would be prominences were they at the edge of the sun. This is the calcium K light, and although that's a very similar telescope with a different filter on it, you actually can't see very much through it. It's only photographically useful. Cameras can see it, but they look more or less dark. I'm told some people can actually see the light a bit better than others, but it's a very deep violet light, so it doesn't register very well in the eyes. That's the sun on the 28th. You can see now the same thing moving on to the 3rd. Our friend 1302 has now moved right over to this side of the sun. And here's a close-up just there. We've got a couple of other sunspots that appeared at that stage. This is 1305 and 1308 over here. This is the sun as of yesterday, the 4th, and you see there's another sunspot that's coming around there as our original one that we've looked at there. 1302 is moving off the western limb, and probably is big enough that it will come back in about 12 or 13 days or so over here. and they tend to sort of move in a direction that's sort of like that, towards the middle. So this being, that edge would probably come in somewhere there around about 12, 13 days from now. And just to underline that point, these are all the numbers of the spots on the disk at the moment. You see we've actually got 8 different sunspot groups there that have been numbered, and I think there's some other areas, if you look around here, of what are obviously active regions that could probably generate more spots in the next few days. So the sun is very, very spotty. If you looked at the sun 2 years ago, you'd probably see it was completely blank. 40%, more than half a chance of being totally blank. But there's lots and lots of activity there. Of course, what's really good about sunspot activity is that you actually get particle emissions from the sun that interacts with the atmosphere near the poles, and you can get auroral activity. And sometimes you can get auroral activity even down to the latitude that we're at, sort of 55 degrees north or so. I'll let you into a little personal secret at this stage that last week I went to New York City to celebrate my 50th birthday and had a great time there. It so happened when I came back, that you wonder what the point of me throwing that in is that I came back on a nighttime flight. So I went to New York Airport to check in and said, "Can I have a window seat on the left of the plane, please?" And she looked at me like, "Why?" Because I'm an amateur astronomer and I want to see the aurora. I picked it not at a good time. It's just one of those things that I was actually right at the lull between 2 periods of auroral activity. But never one to let these things bother me particularly. I did see the auroral band, but I have to tell you that it was visually to me monochrome, because it looks like a sort of a white fog on the horizon as we went over the southern tip of Greenland kind of area at the local midnight time. So I could see something, but it wasn't bright enough to actually activate the rods in my eyesight, so it didn't look green to me. But again, I've never allowed such things to bother me. So I got my little compact Lumix camera, and that has a mode called Starry Night mode, which gives a 60-second exposure. So I just did that, held it up to the window, and wondered what would come out. What it does, it's a 60-second f2.8 exposure, but it doesn't actually crank the ISO up at all. So it's at the bottom ISO of the camera, which is ISO 80, and then it subtracts a dark frame to try and get rid of some of the noise that long exposure generates. Anyway, I'll show you what it does. Now that's the auroral band taken with a compact camera just out the window of flight Continental 94 from Newark to Aldergrove. There's a lot of light here. That's the light on the tail of the plane. So this is the bit we're interested in here. This band. It's there. It's not great, but it's an aurora. And you can see the distinctive green colour of it. Rather better than that, there were guys on the ground in Alaska 2 days previous who managed to get this, which is a bit more like it. That really is, that's worth going to Alaska for, isn't it? But I'll tell you what, I do firmly believe the level of activity on the sun, the way it's going now, sooner or later you'll be able to see that from here. Sooner or later it will get to the stage where there'll be that brilliant combination of that happening and a clear night. I think it last happened anything like that about 2003 here. In fact, the very first day that I came to live here, there was an aurora, and then there was only like 1 or 2 more since. So, but that's how it is. So we're looking forward to something like this happening in the not too distant, all because of solar cycle 24. I'll move on. We've got a couple of different renditions of the same thing here. If you cast your mind back 2 weeks to when Andy was talking to us a fortnight ago, you remember that he showed us the path of Mars through Messier 44, Beehive Cluster, or Persepi as some call it. And that happened on, was that the 30th, 1st of October, thereabouts, yeah. I think this is, this was the 1st of October. This was taken by Pete Lawrence, who you've probably seen on the sky at night. I've actually been corresponding with Pete for many years, since before he was famous, so that's, there you go. And he took this from Chelsea, where the weather seems to be fantastic all the time, as far as I can tell. Here it was the monsoon season when that happened, so we missed it completely. That is Mars there, passing through M44, the Beehive cluster. And I think that Pete would probably have had to have been up about 3 or 4 in the morning to get that, because it's a morning object at this stage. Our own John McConnell, however, got a similar picture 4th of October, and you can see here, actually I think in some ways this is a better picture, because what I like about M44 is the way that it actually sits in this triangle of 3 stars here. There's 2 stars there called Acellus Borealis, Acellus Australis, and that's Eta Cancri. And M44 sits beautifully inside that little triangle there. And Mars, by this stage, 3 days later, has moved out of the cluster and further on down towards Leo in this direction here. And so that was the first bit of clear weather that John managed to get before, well, before today, really. So that's that. There is still a supernova visible. It's fading away now. It's faded by about a magnitude or so since it actually erupted at the end of August, but it is still visible in a telescope or here on a photograph. This isn't a great photograph, but I show it because it is the only photograph I've got of a supernova. You know, so it's bearing in mind they only come along every 40 years or so. It's you know, it's something to have. But this is the final chart, and we'll start here with, this is the Tau, should be fairly familiar to most. And we go right up to the end of the handle here to Mizar Alkaid, and find first of all Messier 101. And what you do there is you make an equilateral triangle at the end of the handle of Tau, so Mizar Alkaid, and then where those two form the equilateral triangle. Messier 101 is there. It's not very easy to see, even in a scope, because it is one of those sort of galaxy objects that is very diffuse. As to say that even the core of it's not that bright. It's although because it's quite big, they sort of say the magnitude is about magnitude 8. It's spread out over quite a big area. You can see in my photo here that it's sort of about that big. But that's where it is. Then if you get to the point where you can actually see individual stars there, and have a look here, there's 2 bright stars. Those are, in the normal course of events, the 2 brightest stars in Messier 101. One right near the core there and one just further out. And then you form this isosceles triangle coming out in this direction. The supernova is round about there. Somewhere. In fact, you can see there's the 2 stars there, and here's the supernova. Just here. That was taken with a 200mm lens on my digital SLR camera. And it was taken in a sort of, it was actually on a mount, it wasn't on a moving equatorial mount, but it was taken in one of those sort of hit and hope manners where I just could point the thing and go, it's about that way, and take some pictures, and there it is, yeah. I actually got it quite near the middle of the image actually, which is not bad, but so that's about down towards magnitude 11 or so now. Probably won't be visible for very much longer, but if you want to see a supernova, that's probably your last chance for quite a while, unless Bath observes as the decent thing or something. There is another space station in the sky. Unfortunately, not for us, I'm afraid. A Chinese space station, Heavenly Palace, or Tiangong-1, as they call it. Was launched from the top of a Long March rocket in China on the 29th of September and is now in orbit around the Earth. However, that orbit is only 42.8 degrees inclined to the equator, and what that means is that you have to be not quite 48 degrees south, 42 degrees south, but you have to be there or thereabouts. For example, we can see the International Space Station here, but it never comes more than halfway up the sky, roughly, because that is in a 51.5 degree orbit, so that's close enough. We're at 54.6 or thereabouts, so we can actually see the International Space Station. We can't unfortunately see the Chinese one, but you can, the guy here demonstrates, you can see it from North Carolina. And I'm told the report that goes with that says that it is very much a naked eye object. It's not as bright as the ISS, it's not as big, but it is very much visible. And the Chinese have got 3 missions lined up to go to that space station, the first of which will be unmanned and will just take more stuff up. The next 2 will be manned, so by sometime next year the Chinese will be in the manned space station game themselves, which is an interesting development for those of us who think probably that the next man on the moon will be a Chinaman, but they're making great strides. Another picture of Pete Lawrence. I couldn't not show this because it's such a fantastic photograph. And I've sent Pete a query about it actually, because apart from the fact that here is a fantastic picture of Jupiter, and see how the missing equatorial belt that was not there last year has come back, very much so. Here is the moon Ganymede, and here is the shadow of Ganymede on Jupiter's surface. So that's an interesting one. And this, of course, here is the Great Red Spot, a storm that's been going on for hundreds of years, comes and goes a bit. But what I actually sent a query to Pete, who's not come back to me yet, is that what's going on here? Is that 2 other red spots that have appeared in that equatorial belt, or is that something significant anyway? Do you have a view on it, Terry? Or?
Yeah, you get those every so often on that edge of the south
so it's not anything too exciting.
North equatorial.
Just a bit of weather going on Jupiter's disk.
That's the classical inverted image with south at the top.
Yes, indeed. Yeah, so that's Jupiter. And that really is it. Jupiter, by the way, is very, very obvious in the sky. If you want to see Jupiter, then just any time, late evening, sort of look southeastwards or southwards around just after midnight. It comes to opposition at the end of this month, where it will be its very brightest. It comes to magnitude of about -2.9, which is pretty bright. Not quite as bright as Venus ever gets, but certainly the next brightest thing after Venus in the sky. So that's Jupiter. So I was just going to mention just one other thing that's turned out to be a complete damp squib. I was rather surprised today. Having been away, it took me until today to actually pick up Astronomy Now, and there's this great article that says, daytime comet, and I'm going, I missed something here. Not daytime, naked eye. Daytime would be fantastic, but naked eye. Saying that there's comet Elenin was going to be magnitude 4 any day now, and it's not. It's not going to happen. This is the path of comet Elenin, and so round about this sort of time, it'll be coming into Leo, which means it'll be far enough away from the sun that you should be able to see it. If you get up a couple of hours before dawn in the morning. But here's the bad news, and this is the magnitude plot of comet Elenin, and this is when it was first observed a while ago, magnitude 20, and then the predictions went right up to here that it would be magnitude whatever. That's about 5. Sorry, this is the predicted one. It comes out white on here. That's clever, isn't it? That's why I'm not seeing it. This is the observed one, the red. The white line that you can't see goes up through there. Says that it's going to be magnitude 4 by sort of October time. And this was the peak here. And it never happened because it was going just fine up to here, and then something suddenly went wrong. These black dots are the observations, and it got fainter and fainter and fainter, and it's now down back to sort of magnitude 10 again. It's believed that the nucleus of the comet broke up. It's basically disintegrated, and so there'll be no naked eye comet in October. But never mind, there'll be more coming sometime soon. That's all I have to say. Thank you very much.